Welcome back, guys. In the last video, we got started with Terraform on Azure. We created resource groups and then we created a bunch of configuration files. Saw how output and variable works. We're gonna extend our Terraform skill sets and gonna create more resources onto Azure, and we would be referring to Azure documents 2 and 4. So make sure that you have got your Terraform for Azure documentation handy. So let's go ahead and create some storage accounts. I'm gonna use the Azure documentation. Go to storage accounts and use the code. I'm gonna copy paste right over there. So I'm gonna use the boilerplate code over right from the documentation. All right. And then just to give you a gist about the code, that's the resource we want to create, which starts with the resource keyword and then the type of resource, which is storage account. So that's what we have given here. We're gonna change this to storage, and then the name we're gonna variabilize it. Remember, we talked about that everything needs to be variabilized. That's the best practice. Storage name, and we're going to define it in our variable. It's gonna be variable and then the storage name. Put that into our demo.auto.tfrs. Storage name Azure RMTF demo storage. Alright, let's go back to our main file. So yeah, we've variabilized it, and then we are using a standard key. I'm gonna remove the interpolation because we're using the latest Terraform, so that is not needed. So interpolation were needed before 12 version, 0.12 version, which is not needed anymore. In Terraform, we also have in the variable section, we can also define maps and list. So let's see how we can define maps. So let's suppose we have got tags here, tags over here. Generally, in the real life scenario, we would have multiple tags, or like the environment, department, cost center, owner, things like that. We would not have one tags over here. So let's suppose we have these tags, and these tags are used, can be used in all of the resources. So if we see how we can define these maps, we can simply define the variable and then the tags, and we can define the type as map here, and then go to our demo.tfr, go to tags, and define the tags as a key and value. So maps are nothing but key and value. So your key in this case would be could be environment, which is demo, and then owner is equals to probably my name, and then purpose is equals to Terraform demo again. So probably these are few of the tags which is gonna stay same across all of your environments. So what you can do is you can simply define that into your main file. You can define in your resource group as well. Tags equals to var dot tags, and same goes for your storage account as well. Alright, looks okay. Let's probably do a Terraform validate. So Terraform validate is one of the command which you can use to validate your syntax, and commands you've configuration you've written is right or not. So if you enter validate, you see that it has straight away given you an error that on line 11 you haven't defined the right configuration. So over here, remember in the last video talked about that's the local value which would be used to call this particular resource later. So in the storage account, we have defined name. However, we want to use the resource group as well. So in terms of resources, we're going to use the same resource group we have used above. So to call this particular resource group, what we do is we use the API name, then the local value, which is resource group. In this case, it should be resource group, and then the name. Similarly, for location, it's going to be the API name dot local value dot location. So we're going to replace the local value example with local value. And now if I do a validate, it shouldn't give any error, and yep, it says that the configuration file is absolutely valid. Alright, so that's one thing. By the way, you can define your hardcode your provider as well. So let's suppose you're using Azure RM and you want to keep your Azure RM plugin version uniform across your team. So what you can do is you can simply define it over here. It should be greater than or equal to 1.40, 1.14 dot 40.0. So Terraform is going to make sure that your version of plugin is downloaded is greater than or equals to 1.40. Alright, so we're going to create a bunch of more resources. I'm going to go back to the documentation. I'm going to create some containers as well. So if I go to container code and pick up the boilerplate code right from here and paste it here, we'll see that the same again, the resource index and then the type of container. We're going to variabilize this as well, var dot container name, put that in the variable section, container name, and then go back to the demo.tfr and define the container name right over here, which is gonna be tf demo container. Alright, sounds okay. And then we're gonna use the container type as private. We're gonna remove the interpolation and maybe from here as well. Cool. If you see that we're gonna hit by an error again if we're gonna use the same code. So resource group ref should be referenced, name of the resource group should be referenced as name of the API dot resource group dot name. So we're gonna replace the example with dot resource group. Similarly for location, and if I do a Terraform validate, alright, so we did a typo over here. This needs to have a storage account, so we need to refer storage account over here. So it has to be storage account, that's the API dot storage dot name. So I'm going to replace the resource group with storage and do a validate again and see, yep, the configuration seems to be valid now. Remember we talked about count in the previous section. The count is one of the expression in Terraform you can use to create multiple resources. Let's suppose you want to create multiple count containers into Azure. So you can use count, and instead of defining these containers again and again manually, what you can do is you can simply use a keyword as count. Let's suppose you want to create 4 containers, and what you can do is you can define the container value, and you can define like count dot index. So the count's gonna start from 0, and now it's gonna create the name as var dot container, which is the container name we have defined right over here. Container name is demo, tf demo container, and if you go to main, the name would be tf demo container. If I show you what the name would be, it would be tf demo container, which is the value of var.container, and then the count.index. Count.index is going to start from 0, so it's going to create 4 containers like this. Terraform dot tf demo container 0, tf demo container 1, 2, and 3. So that's how it's going to use the count.index and create 4 resources for us. Looks like we did a typo over here in terms of syntax. So we're gonna put some two quotes beneath the variables and run a Terraform validate again and see. Oh yeah, that's been successfully run now. And you can use the same interpolation, same count into your output file as well. So let's suppose we would like to get the value of storage. So that's gonna be Azure RM storage. If you go back to our documentation, we would like to output the storage, which is gonna be resource name dot storage dot name. So I'm gonna copy this, put that into the output, making sure there's no typo, and then call the name. Similarly, I can output the container as well, container, and that's gonna be container API dot example dot name. So I'm gonna copy this, put that right over here, replace the quotes with the dot, and then dot name. Since you have used a count over here, we can either use a star so that it'll give us all the value, or you can, if you want to fetch just the one of the values of all the 4 containers, you can use any of the 4 indexes. So I can use 0 and it's gonna give us the first container name. Alright, let's run a Terraform plan. Alright, looks like we have made a typo. So I'm gonna go back to my example and remove the dot so that example first value can be picked. If we do a plan now, it should be giving us a plan of the entire configuration we have written so far. Alright, yep, you can see that it's going to create a bunch of resources. Plus sign denotes that it's going to create a resource group first with a tags in it, and then create a storage account. That's the value of the storage account we have given, and then the tags again, and then the storage container. That, remember, we've used count, so that's going to be creating 4 containers for us. Name of the container is going to be tf demo container 0. That's what we have understood in the last in the example. Should be tf demo 0, tf demo container 1, container 2, container 3. Alright, let's go ahead and apply our configuration. Let's type in yes and wait for the Terraform to create resources on Azure. This is going to take few seconds, and then it's going to create all the resources we have defined in the configuration. So you can see that it's starting to create the resource group. Looks like it has already created the resource group. Then now it is trying to create the storage account. It's on to this part now, and now once the storage account would be done creating, it's going to start creating the 4 containers for us. Alright, you can see that the containers are being created as well. So it has added 6 resources, and we have gotten all our output name. So we have gotten the output of container, which is the first one. Remember, we have in the output section we have used the first container. We wanted the value of the first container, so we've used a 0 index over here, and then we've got a resource group name which we've defined over here, and then the storage name which we have defined over here. If you go back to our Azure portal and then go to resources. That's the resources we have created, and then underneath it we have created a storage account. And if you go to containers, see you've got the tags as well. If you go to container, you'll see all the four containers listed right over here. Cool. That's about the resources. You would notice that it has Terraform also created a state file. So state file is basically a database for Terraform. Terraform stores about your information about your managed infrastructure and configuration. It is used by Terraform to map real world resources and understand what all resources it has created and what all resources it needs to delete when you give a delete destroy command. It's a simple state file are simple JSON files which kind of stores all your information. If you see that the version of Terraform defined over here, and then the container which are being created, resource group, storage account. So generally it is created in the working directory, local working directory, but that's not recommended at all because this has got a sensitive information. You don't want to keep it in unencrypted in your local desktop. Moreover, if you're working on a system, you have created a bunch of resources. Somebody working in your team doesn't know which all resources are being created because he doesn't have the state file, and Terraform only works on state. So for example, if you delete the state file, Terraform won't understand that it has got any resources or not, and it's going to start creating the resources again. So the best practice says that you should always keep your state file in a remote state. Remote state is like keeping your state file in a blob storage where everybody can pull and push the state file, and everybody in your team can work together. So if you do a Terraform state list, you would see that all your resources which are being created using state are being listed over here. One of the things we've seen in real life scenarios that if people want to delete any resources, they what they do is they delete it manually from the portal, and then they try to, let's suppose I wanna delete the resource group. So what I've seen is people doing deleting this particular block right from here, and which is absolutely not recommended because it kind of disrupts your state file, and there could be indentation errors, and you should always not manually making change on the state file. Even if you want to delete something, what you can do is you can use Terraform state rm and then the resource name. Suppose you want to delete one of the containers, so what you can do is you can simply use this container name, put that into the quotes, and hit enter. You would see that Terraform has successfully deleted the resources from its state file. Though the resources still exist over here, if you hit refresh, you would find the container right over here, but Terraform has deleted it from its state. Now, if you do a Terraform plan, you would see that it would be asking you that it hasn't got all the resources onto its state. It's going to create one resources for you. You would see that, yep, that's the resources which we have deleted, and it's going to create resource for you. So yeah, so you can use Terraform state list, and then you can use probably a Terraform state rm and then the name of the resource, and then delete it as well. You can do other stuff as well, like Terraform state show or Terraform pull, push, move resources into different. We're gonna see them one by one in our next videos. So yeah, so as of now we have kept our Terraform state locally, but that's not recommended. What we would want is we should be keeping the state file in a remote location where it's encrypted, and everybody in the team can kind of use those files and have their latest copies of state before running Terraform init plan and make sure that nobody else runs Terraform at the same time. So let's see how we can create the state remotely. We're gonna create a file named backend.tf. Gonna go back to our documentation and gonna type in Terraform Azure backend. We're gonna pick up the code right from here and then put that into the backend.tf, and what we're gonna do is we're gonna use all these containers and resource group name. So resource group name we're gonna pick up right from the output, paste it onto the resource group section, use the container name, put that right over here, and then the storage account name. That's the key wherein Terraform is gonna save the state file as into. So your if you log into, once you've initialized this and applied anything, planned anything, you would see that inside this resource group we would have a storage container, and under the container we would see our state file name prod.terraform. You can give it any name like demo tf.terraform tf state. So now if you do a plan, first let's initialize it because we have written multiple configuration file. So if you notice that it's going to ask that as of now we have been keeping your state files locally. Now what it's going to do is it's going to create a backend for you and going to store the state file over here. So if you go back into your Azure storage in the container 0, you wouldn't find any container demo dot. So you see that as soon as we have done a initialization, it's created the state file right over here. If we hit S and do Terraform plan, refreshing the state, and if we do a Terraform apply, then we would see that all our state information are now going to the remote backend. Apply, and I'm going to auto approve as well. So it's reading the state file and updating the resource configuration onto Azure, and then you can see that now it's storing the state of your infrastructure into Azure Blob storage. That is our remote state. Create the resources, but the resource is already there because we just deleted the resource from the state, not from the actual infrastructure. Now if you open the state file, you can simply download it or lease it or lock it, whatever you wanna. So that's one of the ways you can maintain your keep your state secret, and yeah, that's been recommended when you're kind of working in the team rather than working alone. All right, that's pretty much all. We'll be back in a while and create a bunch of more resources onto Terraform and push our changes onto GitHub as well.